everyone. In this video, we will be changing a general form of a quadratic equation to its equivalent vertex form or graphing form by completing the square, and this is the fourth part. In this part, the value for a in the general form is greater than 1. Now let's take this example right here. We are supposed to change the given general form of a quadratic equation to its equivalent graphing or vertex form. So the equation is y equals 2x squared plus 5x minus 1. As you can see here, the value for a is greater than 1, which is 2. So the first thing that we're going to do here is to put this constant that we have here to the left side of the equation. So we can do that by adding 1 to both sides. So that's plus 1 and plus 1, so that we can cross the 1 right here. So we're left with y plus 1 equals 2x squared plus 5x. So we are going to factor out the 2 here so that we can have a coefficient for x, which is 1. So we can go ahead and say y plus 1 is equal to 2 parentheses. So we're using the distributive backwards. So that means what do we multiply to 2 so that we can get x squared? So that would be x squared right here, so that if we distribute this 2 to the x squared, that comes out to x squared. Plus this one right here, the 5. How do we get the 5 here? We are going to have 5 over 2x, so that if we distribute this 2 multiplied this by 5 over 2x, that will come out 5x. Or pretty much these two should match up every time. So that's a quick trick so that you can come up with a fraction that would work for this part here. So that we are going to create a perfect square trinomial for this by completing the square. That means we're going to add blanks to both sides. So that would be now, what do we put inside the blank? So we are going to use the b value of the ones inside the parentheses, which is positive 5 over 2. And then the same thing as what we did from the other parts, we are going to divide this by 2. So I'm just going to show the work right here. So we're going to divide this by 2 so that this would come out 5 over 2 divided by 2. So this is a complex fraction. Remember that this 2 in the denominator here has an invisible denominator of 1. So what are we going to do here is that we are going to copy the fraction on top, which is 5 over 2, and we are going to flip the fraction at the bottom. That would, instead of writing 2 over 1, we're going to flip it. So that would be 1 over 2, and we multiply them across. So that would be 5 times 1 is 5, and that is over 4. So we get a 5 over 4 when we divide it by 2. Now, after we divide this by 2, we are going to square it. So I'm just going to show the work on the bottom right here. Okay, so what I did was I squared this 5 over 4. That's the next step that we got here. So once we square it, that would be 5 squared is 25. 4 squared is 16. And whatever this value here, that's the one that we put in here so we can complete the square. So that we go ahead and remember that there is a 2 in front of the parentheses. These 2 can be distributed to each of the terms inside the parentheses. That means that we are not adding 25 over 16 here because we got a 2 here. We are adding actually 50 over 16 because that's a 2 right there. So we are going to add on this side would be 50 because you have 2 times 25 is 50, and that is over 16. So that we can go ahead and simplify this equation that we have up here. So I'll show the work on the side right here. So what we do is I will copy all of these. So that would be y plus 1 plus that is 50 over 16, and that is equal to 2. Now, please remember that this part right here is already a perfect square trinomial. We did that by completing the square. Now, we are going to write x here. Now, we remember the fastest way to pair up with x here it is this number that we squared. So whatever this is, that's the one that we pair up with the x here. So that is a positive 5 over 4. So I'm going to write plus 5 over 4. And then that's a squared because it was already a perfect square trinomial, meaning if we are going to use the area model or the FOIL method, we multiply x plus 5 over 4, multiply it by x plus 5 over 4 because it's twice. That means it will come out to this, x squared plus 5 over 2, x plus 25 over 16. Now, if you notice, these two here cannot be added together, the 1 and the 50 over 16, because they don't have the same denominator, so that we can go ahead and multiply the 1 by 16 over 16, so that this would come out so that we can go ahead and add these two together. So that would be y plus 66. You have 50 plus 16 is 66 over 16. And that is equal to 2 parentheses x plus 5 over 4 squared. This 66 over 16 can be reduced to the lowest term. We can have this as y plus 33. This is divisible by 2, so that's 33 over 8 is equal to 2. That is x plus 5 over 4 squared. Now, we want to have y by itself on the left side of the equation, so we subtract 33 over 8 minus 33 over 8, so we can cross this out. We are left with y is equal to, that's going to be 2 parentheses x plus 5 over 4 squared minus 33 over 8. And this is actually the graphing form or the vertex form for this quadratic equation that we have up there. If you notice, our vertex for this is, we remember that we're supposed to switch and keep. So the vertex would be negative 5 over 4, and that is negative 33 over 8. So this is the vertex of this equation that we have here. So pretty much the importance of changing it to vertex form is that just by looking at this, there's no way that we can determine the vertex using this equation. However, if we have the graphing form or the vertex form, we just go ahead and switch this h and keep this k. We got the vertex. On this side, you will see the graph of these two equations that we have here on Desmos. That is in blue, that is y is equals to 2x squared plus 5x minus 1. And its equivalent graphing form or vertex form in red, which is y is equals to 2 parentheses x plus 5 over 4 squared minus 33 over 8. We can see that in this picture, these two are actually on top of each other. So they are sitting on top of each other, which means that they are equivalent. That means these equations are pretty much the same thing. If you notice, the vertex as well is located on negative 5 over 4, or and that is negative 33 over 8, or we can change this to decimal. Negative 5 over 4 is actually negative 1.25, and negative 33 over 8 is actually negative 4.125. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we are going to move the 5 to the other side of the equation. So we're going to subtract 5 to both sides. So this would come out. Okay, the next thing that we're going to do is to factor out the 3. So this would come out y minus 5 equals 3 parentheses x squared minus 7 over 3x. Again, you notice that these two should always be the same. In the first example, this was a 2, but this is a 3, so we put a 3 over the 7 here. So we factored out the 3 so that we are going to make this into a perfect square trinomial by completing the square. That means we are going to put blanks on each side. So I'm gonna write that up here. Okay, so the one that we write into the blank here would come from the value of b. So what are we going to do is we're going to divide this by 2, and whatever the value is, we're going to square it. So I'm going to show the work down here. Okay, so what I did was I divided the b value with a 2. And so again, we remember this is a complex fraction. We keep the fraction on the numerator, -7/3. And we are going to flip the denominator, that's 2/1. So that becomes 1/2 and multiply across. So that is -7 times 1 is -7. 3 times 2 is 6. And we're going to square it. So -7/6 squared would mean 49/36. And this is going to be a positive, since a negative and a multiplied by a negative is a positive. So that's the number that we add to this blank right here. So I go ahead and write 49/36 on this blank. Now, please notice that we are adding 49/36, and that is actually multiplied by 3, because you have a 3 in front of the parentheses, which means that we are going to multiply 3 times 49. That is equal to 147. And so 3 times 49 is 147/36. So that we can go ahead and rewrite this equation that we have up here. So I'm just going to show the work up here. Okay, now please remember that this is already, after we completed the square, this is already a perfect square trinomial. Now, we remember that we write the x here. The partner of the x is always the one that we square on this side. So it is this one right here. So that's a -7/6. So I will put that next to the x. So -7/6, and that's a squared. So that means if we are going to use the area model or the FOIL method for these two, we're going to multiply these x minus 7/6 twice. It will come out to this. So that we can go ahead and we also notice that this 5 here and the 147/36 cannot be combined together, since they don't have the same denominator. So that means I will multiply this by 36/36 to make their denominators the same, and this would come out. Okay, so then we can go ahead and combine these two together, these two fractions. So that would come out y minus -180 plus 147 is 33/36. So it's a minus because you have a -180 plus 147 is a -33, and that is over 36, and that is equal to 3 parentheses x minus 7/6 squared. Now we want to have y by itself on one side, so that we can go ahead and add by the way, this 33/36 can be reduced to its lowest term, so we can still reduce this. So that is y is equal to that's 33/36. This can be reduced to 11/12, and that is equal to 3x minus 7/6 squared. So then we want y by itself, so we're adding 11/12 from both sides, so plus 11/12. We can cross this out. We are left with the graphing form or the vertex form of this equation right here, which is y is equal to 3 parentheses x minus 7/6 squared plus 11/12. So this is the graphing form or the vertex form of this equation that we have up here. Now notice that the vertex for this graph, it would fall on switch, so that would be positive 7/6, and keep, so that is 11/12. So this is the vertex if we graph this two equations in the Cartesian coordinate plane. On the side, you will see the graph of these two equations on Desmos. The first one is in blue, which is y equals 3x squared minus 7x plus 5. And its equivalent graphing form or vertex form in red, which is y equals 3 parentheses x minus 7 over 6 squared plus 11 over 2. You can see that both of them are on top of each other. So that means these two equations are equivalent. So they are just the same. They just come in different form. And if you notice, the vertex is located on negative 7 over 6, or if you notice, the vertex is located on 7 over 6, or pretty much that's 1.167, and 11 over 12, which is pretty much 0.917. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!